Alrighty, good afternoon, students. I'm going to be coming to you guys out of the course workbook. Okay, this is the thick book right here. Alrighty, and I'll be coming to you guys from page 14, and I'll be working on page 15 as well. The title of this section is section 1, topic 5, and it is adding expressions with radicals and rational exponents. Okay. I was gonna do a video based off of what I taught today, but I think the lecture notes that I posted in Teams is good enough for you guys to recognize what you guys should do and what you guys should not do. Okay. Periods 1 through 5. Make sure you look at the lecture notes because I took out a slide that I used in the lecture notes that I really felt like it was kind of hard for you guys to understand. And then not only that, but it wasn't a part of the topic for section 4. Okay. It's more so for this section, section 5. So make sure you guys just pay attention to those lecture notes to understand today's lesson. But then if you want to understand what tomorrow's going to be like, then you want to watch this video right here. Okay. So what we're going to do is we're going to go ahead on and look at question 1 in the let's practice section. And we're going to do perform the following operation. It says square root of 12 plus the square root of 3. Okay. Now, what you want to do is you want to try to get to the point where you got the same radicand and the same index for your radical, okay? So let's look at both of them. Both of my square roots, so we got the same indexes. So the index is 2 because it's a square root, but there are different radicands. One is a 12, one is a 3. So we want to see if we can make them to be the same ones. If not, then we leave it alone, but if possible, then if we do get the same radicands, that means we can do some adding and subtracting, all right? Adding or subtracting. But in this case, we're gonna be adding. So you look at the bigger number, which is 12, and you try to break 12 down, okay? So you look at the factors of 12 and you wanna pick out what factor of 12 is a perfect square. And when we say a perfect square, we mean that you can take the square root of that number. And that'll be 4, okay? And 4 can divide 12. So 12 is the same thing as saying 4 times 3, okay? And then we still got this plus 3 right here, or plus square root of 3, so I'm gonna write that out as well. Okay. I can split this apart. This can be the square root of 4 times the square root of 3, and then plus this square root of 3 as well. The square root of 4 is 2, okay? So I have 2 square root of 3 plus another square root of 3. All right, so I'm almost done. This is where the part I want you guys to pay attention to is that I have a square root of 3 here, and I have another square root of 3 here. So these are what we would call like terms, all right? So you know how sometimes when we do 2x plus an x, and those are like terms, and we can add them together, they'd be 3x. So this is a 2 square root of 3. We can add this square root of 3. If you add them together, you're going to get 3 square roots of 3s, okay? And that'll be your answer for that one, okay? And that's it. All right, let's skip over to 1D, okay? So for 1D, what we have is 72 to the 1/2 plus 15 to the 1/2 plus 18 to the 1/2, okay? So what we want to try to find is, we want to try to find to see if we can get them all to be the same radicands with the same indexes as well. So I know that the rational exponents kind of confuse students sometimes, but remember today we went over our rational exponents property, which states that if I have an expression that has a rational exponent, I can write it as a radical, okay? The denominator is always going to be the root or the index, and the numerator is always going to be the power, okay? So in this case, 72 to the 1/2, we can rewrite this as the root is 2, 72 to the first power. Now, since the root is 2, we always assume that to be square root. Okay, so we really don't have to write 2. You can if you want to. So I'm just going to change all these to square roots because all of them have 1/2 as a rational exponent. So this becomes plus the square root of 15. And this is plus the square root of 18, okay? Now what I want to do is I want to see if I can break down these roots, okay? Possibly to make them all be the same root. 72 is not a perfect square root. However, you want to pick out a factor, which means that you want to pick out a number that can divide 72 that is a perfect square root. So in this case, it's 36. Now, if you didn't know that, you can probably try to do 9 and 8 and then break it down more from there, okay? But I'm going to choose 36, okay? So this is the same thing as saying the square root of 36 times 2, okay? Because 36 times 2 gives you 72. So we also have still 15. 15 doesn't really have, 15 is not a perfect square root. Neither is any factors of 15 a perfect square root as well, okay? So we're just gonna leave 15 alone. This is still gonna just be plus square root of 15, okay? 18. 18 is not a perfect square root, but it does have a factor that is a perfect square root. And that factor is 9, okay? So 18 is the same thing as saying 9 times 2, all right? So we look at 36. What is the square root of 36? It's 6, okay? And we still have this 2 is still gonna stay on the inside of it. This 15 is still gonna be there as well. This 9, the square root of 9 is gonna be 3. Okay. So since that's the case, we have a 6 square root of 2, we have a square root of 15, and we have a 3 square root of 2, all right? The two terms, the 6 square root of 2 and the 3 square root of 2, are like terms. The reason why is because they have the same index, meaning that it's a square root, and they have the same radicands, which is 2. So we can add those together, okay? And this is going to be 9 square root of 2 plus square root of 15, because 6 plus 3 is 9, okay? And then that is my answer for this one. Okay. If you want to take a moment, pause it, go back, then you can. If you understand it, then let's go ahead and go to the next one. We're going to do 1e, okay, 1e. So 1e, you have the square root of 32 plus the cube root of 16, right? So we can already see that these are two different indexes. One has a square root, one has a cube root. So we can't even add these if you wanted to at the end, right? So let's go ahead and still break it down though. So 32 is not a perfect square, but you want to pick out a factor of 32 that is a perfect square. In this case, I'm gonna choose 16, all right? So 32 is the same thing as saying 16 times 2. Okay. And then over here for my cube root, 16 is not a perfect cube root, but there is a factor of 16 that is. And what I mean by that is that you have to pick out a number that when we talk about cube roots or a perfect cube, we mean what number that if you took another number and multiply that number by itself 3 times, you get this particular number. And that number is 8, okay? 8 is a perfect cube. So 16 is the same thing as saying 8 times 2. Okay. The square root of 16 is 4. So it's going to be 4 square root of 2. The cube root of 8 is going to be 2, okay? Because 2 times 2 times 2 gives you 8, okay? And then you're leaving this 2 still inside the radical. So if you look here, you have 4 square root of 2, and then you have a 2 cube root of 2. Again, even though they have the same radicands, the indexes are different, okay? So you can't add them. So this is where you stop at, and this is your answer. Okay. Let's go over here to the triad area. Okay. We have 6. We have the square root of 6 plus 3 square root of 6. All right. 6 is not a perfect square. Neither are any of its factors. 3 is not a perfect square, neither is 2. Okay. So we leave 6 right there up on this radical. We have the same radicand up under this one too as well. So we can't do nothing with it. However, since both of them are square roots of 6's, okay, this is 1 square root of 6. This is 3 square root of 6. So we can add those together because they're like terms. And so the answer is going to be 4 square root of 6. Okay. We can come over here to the beat the test part. Right. So it says here, which of the following expressions are equivalent to 3 times the square root of 2? Select all that apply. Okay. So we can try to see what we can do here. So this is 3 to the 1/2 plus 2 to the 1/2. Okay. So what this is saying is that this is the square root of 3 plus the square root of 2. Can we add these together? No, we can't, because even though they have the same indexes, they have different radicands. So this is what this expression means, and that is not the same thing as 3 square root of 2. Because what we're looking for is to get to see which expressions are equal to 3 square root of 2. So that's not one of them. Okay. Let's try the next one. Next one is 8 to the 1/2 plus 2 to the 1/2. Okay. So we can write this as the square root of 8 plus the square root of 2. Okay. 8 is not a perfect square, but we can break it down to a factor that is, and that's going to be 4. So this is the same thing as saying, or 8 is the same thing as saying 4 times 2, right? And then we still got this plus square root of 2. The square root of 4 is 2. It's going to be 2 square root of 2, and that all came from right here because this 2 stays on the inside. And then we have plus this square root of 2 right here. Okay. We can add these two together, and that's going to be 3 square root of 2. Okay. And that is equivalent to that one, so we will check off that box. Next one is going to be 3 times 2 to the 1/2. Well, what this is saying, this is the same thing as saying 3 times 2 to the 1/2. That's the same thing as saying the square root of 2. And that is equivalent to what we have here, so we're going to check that box off too as well. Okay. 18. Okay. 18 is not a perfect square, okay? But we can break 18 up into a factor that is a perfect square, which is 9 times 2. Okay. The square root of 9 is 3. So this is going to be 3 on the outside and 2 stays on the inside. And then we're done there, and that is equivalent to that one, so that one gets checked off too. Okay. And 2 times square root of 18. Okay. Well, again, we got 18. It's the same thing as saying 9 times 2. And then we also got this 2 already on the outside already. The square root of 9 is 3. So this is going to be saying 2 times 3 square root of 2. Okay. So if I multiply these two things together, just multiply these two coefficients, that's going to be 6 square root of 2. And that is not equivalent to what we have here. Okay. Lastly, we got the square root of 8 plus the square root of 2. Square root of 8. Well, that's kind of like what we did up here already before. So we already know that that's the equivalent. So yes, that's the one. Okay. So that's all I want to do for now. If you want to go ahead on and try to do the rest of the beat the test, then you can. Okay. It says here, Miguel completed a proof to show that square root of 27 plus square root of 3 equals 4 times 3 to the 1/2. These are his steps. He's missing a step right here. You want to look at which part or which one of these expressions do you think belongs in this particular step. You don't have to do it if you don't want to, but if you want to just challenge yourself, then you can. Okay. This is all I will do for today. Hopefully this is enough to prepare you for tomorrow's class. I'll see you guys tomorrow. Have a nice day.